all of you. I welcome everyone in this webinar and thank you for all us for joining us this webinar. My name is Nata Pradip Markers and I am the assistant professor at the Department of Mechanical Engineering, Parallel University. Now I would like to welcome Mr. Divijin Dani sir on behalf of Parallel University. Welcome sir.
Thank you so much, Dr. Pradeep Pash and the entire Parul University management and administration for providing me an opportunity to present this webinar.
From the IIT Misra and submitted PhD thesis at NIT Future. He is currently working as assistant professor at Department of Mechanical Engineering, Sri Siva Subramania Nadar College of Engineering, Chennai. He has over 2 years of industrial experience. His area of interest are decision support system based on AI, ML, green materials, rapid prototyping, supply chain. He has filed 6 patents, authored 8 books, edited 8 books, published over 20 book chapters, 13 SCI journal papers, and 7 Scopus Index International journal papers. He has been conferred with Educational Excellence and Innovative Research Award. Welcome, sir.
Thank you so much, Dr. Pradeep Kash, and I would like to also thank the entire Parul University administration for providing me an opportunity to present a webinar on this platform. Okay, so let me just before I just begin my session, let me a brief introduction was already given by Dr. Pradeep Kash. So yeah, I just take some this is a webinar on the for the green and sustainable technologies that are very much required and are the forefront and should be at the forefront of any decision making policies. But in order to implement them at a very successful implementation, they should be they should be provided some support systems on the basis of which we can just provide short policy advices, also the various sustain and which can help in attaining the sustainability development goals. So this is the webinar therefore on decision support systems for green and sustainable technologies. So before I proceed with the webinar, let me introduce to place where I am currently working in. I am currently assistant professor at SSN College of Engineering, and this has been founded by Dr. Shiv Nadar. He is the chairman of SCL Technologies, and yeah, currently we are located in at this part of the country, that is in Tamil Nadu, that is Chennai, and it is around 40 kilometers from Chennai. It is a very lush green 250 acres of campus, and we have got various BE and BTech degree programs as well as ME degree programs, and currently also we have also rolled out advertisement for PhD enrollments. The institution is well graded with A+ by NAC, and almost all of its programs are accredited by NBA. Sri Subramania Nadar College of Engineering has been ranked 44th in the latest NIRF of 2020 rankings. So that is what is all about SSN. So currently I am working as assistant professor in the Department of Mechanical Engineering. So let's see what the present contents, the contents for the present webinar will be. I will be just providing a short introduction on the webinar that is on the topic decision support system for green and sustainable technologies. Then we will proceed for the classification of various decision making tools or decision support systems, and what are the various key ingredients that make up this or the decision support systems or the decision making tools. The few important and critical applications of the decision support systems pertaining to particularly green and sustainable technologies. Then the case studies, I will be taking few of the case study that will help us familiarize with the decision making support system, so that we will be able to grasp the concept very easily. Then we proceed for the case study on green materials, but that would be a different situation altogether. A case study on electric vehicle I will be discussing. So let us see how the time permits, and we will be progressing further. So I just welcome you once again, all of you, in this webinar. Hope you will enjoy this. It is a late afternoon session, but yeah, I will just try to make it I will just try to avoid your this late afternoon sleepiness or what. I will try my best. So yeah, basic introduction. Let's begin with what is why basically a decision support system is required, and what basically a decision support system is. So when we look at, so decision making support systems, they work primarily through multi-criteria decision making, that is MCDM. And these particularly we are using in order to have a in order to select to go for optimal conditions. We want to classify the alternatives. The alternatives can be any, like if I talk about the alternatives in the case study, this will become more clear. The alternatives, I mean to say, for example, if you are going for purchasing a car, then what segment of car you are going for, like sedan or hatchback you are going. For instance, I am having like 5 to 6 cars on my list, A, B, C, D, E, for example, and I have to find out, like according to my different criterias are there, like criteria, I mean to say, different utilities are there. Like I want to purchase the car on the basis of its cost, on the basis of its luxury, or on the basis of its interiors, or on the basis of its mileage, and so on. So these are different parameters we have to look into, we are taking into account. And whatever the alternatives I am having, like I am confused, which alternative, which car should I go for? Should I go for car A? Should I go for car B? And so on. So even in the electric cars segment also, now we are seeing that Indian market is coming up various with various sedans and hatchbacks. So yeah, this is like if we provide a systematic tool, not only in purchasing, but even also for designing the electric vehicle, the important components that goes into it. If you want to select the particular material for that component, then we are having certain list of the material, and we have to identify the best possible material that can go into it, or the best possible car you should go for purchasing it. So what you do is through the decision support system, we are just classifying all these materials, and finally we are going for the algorithm. And through the algorithm, we are finding on the basis of the various parameters, like the mileage, the cost, your interiors, luxury, and so on, that which car should I go for. So this help us to categorize the alternatives. And yeah, so most of the MCDM methods, or the multi-criteria decision making methods, discrete alternatives are there. Like I said, that you go for purchasing a car, then when you are going for purchasing a car, these are discrete alternatives, like A alternative, or B car, or C car, or D car, and so on. So definitely there is a set of alternatives, and this set of alternatives, these you have to choose, you have to carry out the performance analysis on the basis of certain prescribed performance metrics. Performance metrics, like I said again and again, like for cars, you can go for mileage, you can go for luxury, environmental impact also you can go. So these are the various criteria. So now these criteria, or the performance metrics under which you are going to evaluate these discrete alternatives, they can be classified as cardinal or ordinal, their information. Like if I go for luxury, so luxury, you are saying that a car is giving a good luxury, it is giving excellent, it is having excellent interiors, and so on. But you cannot quantify that luxury or interiors you cannot quantify it. So when you are not able to quantify it, you are having like ordinal as well as cardinal information. So this is one type of information where you are not able to quantify it. Other kind of information is like mileage. You are saying that it should be like 62, 15 to 20, 20 to 22, or so on. You are able to classify this performance performance metrics, or you can classify the performance metrics like the cost. Like the cost should be like between 5 to 6 lakhs. So this is one set of performance metrics, and there is another set of metric that I talked previously, like which you cannot quantify. So these are the set of criteria, two kinds of criteria, cardinal as well as ordinal information. So the information, now this could be it can be exact. As I said, the cost of this car, you are going for like 5 to 6 lakhs, or you are going for 7 to 8 lakhs, whatever it is. So when you are going for this, so this is an exact information, like. But when you are going for like, I should have an excellent interior or a good interior, or yeah, so these are like fuzzy. You are having a vague idea, like, yeah, this car is having an excellent interior, so this car is having only a good interior, so very good interior, very very good interior. So this is a kind of fuzzy information. So this vague information or an uncertain information, they can be classified in fuzzy numbers. So there is an exact information and there is a fuzzy information while you are going for the alternatives. Now there are modern MCDM methods. So this is where this relevance of the decision support systems through MCDM tools comes into picture, because we are in a state of bother, like in a state of conundrum, like where to which car should we purchase or under the metrics. So this is where the MCDM comes into play, and where the relevance, this just justify or simplify the process of decision making. Which decision should you go for? So this is like a common procedure. We can go for a common procedure, or like all the decision support systems, they go for a common procedure. You have to start, it's a kind of iterative loop. You have to define a system. There is a system, like you defined a system with the objectives to be met. Like I have to buy a car, but these are my objectives. This should be the cost, this should be the mileage, and interior should be such and such. So we have defined a system with the objectives to be met. And then this performance matrix, under the performance matrix, we are going to evaluate that objective function. So there are now, what are the alternatives? The third is saying when we say this, so that is the third step, is like we have to define, we have to seek the systems. So what kind of systems are we dealing with? So what kind of alternatives we are choosing for? So that is where the role of this comes. So this is where the third one goes for. Then there are I told you that there are certain criterias. So in case of like purchasing a car, you are going for the mileage, the cost. So these are your performance metrics, like cost is one, like mileage is another one. So you are going with all these things. So these are your criterias. Now you can say that you are weighing, you are relying more on the cost, like on the basis of cost you want to make your purchase. Least you are bothered about the mileage, or you are least bothered about the interiors. So when you are least bothered about the interiors, so there will be some weights, like importance, like I can assign, like for me 50% weight, 50% matters is the cost, and rest 25% for respectively for interiors as well as for the mileage. So I have to set the priority weights. Once I have set these priority weights, then I have to go for a suitable MCDM approach. And once this approach will help analyze the alternatives. So like I had the different car A is there, car B is there, car C, car D is there. So we will now prioritize these alternatives or these cars on the basis of the information that we have gathered with the help of the decision support systems. Then we will be able to find out the optimal one, like which car should I go for, A car or a B car or C car or D car. So if it is acceptable, then it is okay, it is the end of the process. But if it is not acceptable, then you have to again reiterate. You have to see, you can add an additional, like, yeah, I am bothered about the environmental impact, so you can go for EI also, environmental impact. So then you have to again reiterate the process. So when you reiterate the process, this process will be repeated. So this is a common procedure for any decision support system. Now, what are the various classification, how we can classify a decision like MCDM tool or a decision making tool? This is a common perception, like decision making tools. We can classify the decision making tools into various categories, and these categories are like like multi-attribute decision making, that is MADM approach, or we can go for MODM, that is multi-objective decision making. Then, as I told you about the fuzzy information, we can go for fuzzy based tools. And then we are having a classification of gray numbers, like these are also dealing with uncertain and vague informations. So these are the various tools I have listed down. These are commonly used tools. And now we will see that what like we are having top say selector, we are having a simple additive weighing method, Viker is there, GRA, Copras, PSIN. So these are the approaches for MADM. As far as the MODM goes, like life cycle analysis, artificial neural network, goal programming, these are all the MODM approach. So when you mix either the MADM with MADM with like fuzzy based tools, then they become the fuzzy algorithm, like fuzzy topsys, fuzzy Viker is there, fuzzy ANP is there, fuzzy Promethe is there, fuzzy elector is there, and so on. Now, what is the basic differentiation between an MADM and an MODM? So these are the basic tools that will be means our focus for the present webinar will be on this MADM or MODM approaches only, where we are dealing with the exact information. We will not be covering for this webinar the fuzzy approaches because of the time constraints. So what is the basic difference between a multi-attribute decision making and a multi-objective decision making? So let us consider with an example now. The example will help us comprehend the idea more clear. So for example, we are having two objectives. First, I will talk about MODM. Now, for example, we are having two objectives are there. We have to purchase a bicycle. The bicycle should be light and it should have many gears in it. Okay, so these are the two criterias or the two performance metrics on the basis of which I will be purchasing a bicycle. So what we do is usually we will be going for a trade-off between a weight and the gears, because the bicycle should be light and should have a gears also. Why the trade-off would be there? Because we are seeing that if we are going for extra gear, then it will be adding like 100 grams to the bike. So yeah, there should be no trade-off, because you want to have as many gears, but the bicycle weight must also be light. Okay. So what we do is, these are the utilities. So this criteria has to be transferred to the utilities. Let's say that the bike should be heavier than 50 kg. It has no utility, and one that is having 8 kg will be. That means full utility means it will be light also, means it will suit my requirement. With the utility, I want to say that. So if I talk in terms of gears, I will say that if a bike is having say 3 gears, then it has no utility. But if it is having more than 18 gears, then definitely I will go for that bicycle. So that is where like this is the utility on the basis of weight. First, we are saying that if it is heavier than 15 kg, then we will not going for it. But if it is less than 8 kg, then we might consider an alternative. On the basis of gears, I am saying if it is having 3 gears, oh, definitely we can go for it. We are not going for it. But 18 gears, yeah, we can go for it. So particular utility is not there. We are not able to find a particular means objective is not there on the basis of which because there are two different things, weights and gears. I don't know how we will relate weights and gears by weight of the bicycle and the gears. So there is no complete utility is not there. We have to go distinctly, first for the weight, then for the gears. So these are multi objectives, because objectives are weight as well as gears. So what we have to go for, we have to go for the optimal weights differently, and then we have to choose for the gears for the bike, so that we can maximize the utility. So we go for the bike shop, ask whether they have a bike suiting the requirement on the basis of the weight as well as on the gears. Then your classification is multi-attribute decision making. Once again, you go to a shop and you write down the weight and the number of gears for each bike. Okay, then we have to transfer the utility. The same, like I say that 15 kg, it has no utility, but if it is less than 8 kg, I can consider it. Again, if I say that a bike is having more than 3, it is having less than 3 gears, then it is having no utility. If it is having more than 8 gears, yeah, I can say that it is of my consideration. Okay. So weight is a different utility, saying we can say that weight is like I assign more priority to weight, like we assign more priority to the cost instead of the mileage. in the previous example, in the previous slide. So in this, I was saying that weight is mattering. It matters to me most when for the with respect to the gears. So yeah, I can say now there is a utility, like what, that is 3 times the weight plus the gear. So that is the total utility. On the basis of this total utility, now I will be going for my analysis. So now we take the bike with the highest utility. So that is where the difference is. There in multi-objective, you have to go for different objectives. That is weight different, gears different. But here now you can combine the two utilities in case of MADM, and you can go. So the bottom line is, what I mean to say is, so you in case of MADM, that is multi-attribute decision making, we end up knowing which bike we like the most. That is the ranking approach. But in case of MODM, we are saying that what bike you would be needing to build. So that is a design approach. So it is a more of a design approach, and this is more of a ranking approach. Okay. Now, what are the components of a decision support tools? So that is through the important constituents. These are the criteria, as I have been again and again iterating, that there will be certain alternatives, and these alternatives have to be judged on the basis of some criteria. Then on the basis of alternative and criteria, we will be formulating a decision matrix. That is the third constituent. We can have, like I am saying, we are having like if I go for in mechanical terms, we are having tensile strength, we are having mechanical properties such as tensile strength, tensile strain, elongation at break. These all are having different units. So when these are having different units, how can we compare the different alternatives? It will become difficult for us to compare it. Then we go for a procedure that is known as normalization, that can transfer the data, because we have to transfer then only we will be able to make the comparison. So we have to make a common scale for it. So we go for a process known as normalization. Criteria weights, I told you that weight is weighing more 3 times more, like weight in the previous example of bicycle, I told that weight is weighing 3 times more than the number of gears. So that is where the criteria weights come in, the importance on the basis of which, like I said, that cost is mattering 50% more in comparison to the mileage or the other aspects. Then we go finally for the ranking of the alternatives. So the normalization tools are having various characteristics, and for this you can I have just cited the source, Jahan and Edwards. For a proper grasping of this, we can go for, like, it should be able to remove the scales, like this tensile strength in megapascal, and strain is having no. So like elongation at break, the percentage elongation is percentage, so it should be able to remove this scale. Even it should be able to handle the negative value also. Then rank reversal is another concept. Rank reversal, that is what we say, that if we are removing certain alternative from the list, so whether this normalization process will affect the ranking process. No, it should not affect the ranking process. If we are terminating or we are eliminating, like A, B, C, D, E are the cars, but now I am saying no, first I have gone through some procedure of normalization, now I am saying no, I don't want to buy D car. So now you have to go for normalization again. Now it should be symmetric, and it should be able to transform to benefit criteria. There are 2 types of criteria, beneficial and non-beneficial. With different weighing techniques are used. These are like on the basis of internal methods, external methods. External methods without the consideration of the decision maker, and with the consideration of the decision maker. So this is the classification, overall classification of the weighing methods. So there are various methods, and for the present session, we will be laying our focus on the like entropy method. That is, entropy method will be the objective weights, how we find out the weights. One is the subjective, like I said, that it is weighing 50%. It is having on the basis of my perception, on the basis of the decision maker perception. But if you want to have a mathematical calculation also, like I am not clear about, so you can have a mathematical calculations also. So these are the various applications. There are different applications of decision making tools, and particularly for like green and sustainable technologies. If I talk about, so we are having like green material selection. Like for if we want to go for a housing, like we now there are various houses that are being structured on like bamboos only. So if you see that these are all green materials, these are material, but we have to find out which material will suit us, our requirement. So that is a green material selection we can go for. So green supplier selection we can go for. Then we can go for sustainable renewable energy developments also. Like there are various resources of renewable energy resources, or where there are various energy resources that are available with us, and we want to classify like which resources will be suitable for a particular area, like hydropower or tidal power, or the photovoltaic, or the wind, or the and so on henceforth. So for that also we can go for using the decision support system. For green manufacturing, we can go for decision support systems, where we have to like find out what the basic parameters, operating parameter for a machinery we should use, so that whatever the impact is coming on the environment, it can be reduced, or there are other things also. uh, then we can go for municipal solid waste management using the decision support tools. Also, if you want to go for the site selection, like if you I have a site selection for renewable energy based power plants, if I want to go for there are various sites are available with me, on which site should I go and plant my renewable energy based power plant. So for that assessment also we can use the decision support systems. Then for policy responses towards the water shortage mitigation also, we can go for the decision support systems. So these are where the criticality lies with the decision support system. So if I talk about like green materials, so green materials, like one of the case study, present case study I will take, and this is from this is on green material, and this only consider the exact information. Okay, this case like exact information, we will see what kind of information I am talking about through this case study. So there is a tool that is known as Portuguese. It is a Portuguese name is Tomada de Deseo Interactiva Mati Criterio Decision Support Tool. So this is a algorithm is there, and this is where a pictorial representation or depiction of the algorithm is this. We have to go to, first of all we have to formulate the decision matrix, where we have to go for the normalization of the decision matrix, and we have to find out the criteria weights. And then the two important steps are step number 4 and 5, where this algorithms differs from the other algorithms, and that is MCDM. So this algorithm, why it matters to us? Because it will take into account the risk appetite of the decision maker. So let us now take an example. Now, we have done a case study of like green composites that is based on Punica granatum. That is the scientific name of pomegranate. Okay, so there is a cultivation of pomegranate in Maharashtra, and Maharashtra belt, and we have collected like its waste material after its planted, after its cultivation. Okay, so that is a kind of waste. If we burn down, then it will harm the environment. It is lead to global warming, or some residual gases flowing into the environment. So we are using that reinforcement, but we have to find out the optimal reinforcement condition that we can use, so that we can have a better material with us. Okay, so what are the basis, what are the performance metrics on the which on the basis of which I have to deduce the optimal reinforcement condition? Like different criterias are there, different like my material should have good tensile modulus, good tensile strength, elongation and break, flexural modulus and flexural strength. So these criteria are like beneficial criteria, like more and more tensile strength I am having, then my material, yeah, I can go for a good material. So that depends upon the application. So these are the various criteria we are going to take in, we have taken into consideration. Now these are all the exact, because when you are going for the now the composite fabrication, So those like composite fabrication. Then we are putting some reinforcement into some polymetric matrix. So this reinforcement into polymetric matrix, now how much this reinforcement or this material should be put into this reinforcement or the polymeric matrix, so that we can get a material that is having a good tensile modulus or better mechanical properties, I will say. So these are the 5 on the basis of 5. So you are going to test the material, different configurations will be there. You are going to test these materials, and their testing will yield some data, and this data will be like in some ranges or some values will be there. So these are like exact values. Okay. So we have to now identify the suitable list of alternatives for our primary investigations. So these are the list of material. Now what does this denote is, for your better understanding, if I say is, PGF means Punica granatum fiber, that is the pomogranatum fiber is there. Now if it's in raw state, and raw state means we are not going it for its further processing, we are going to just use it as it is, and its 10 weight percentage we are going to take into for the polymeric matrix. So for the you can take any polymeric matrix. For this we have taken as epoxy resin. So this epoxy resin we have taken. Okay, so in that epoxy resin 10 weight percent will be of Punica granatum fiber. If I say PGF 1D and 10, that means this Punica granatum fiber has been dissolved, has been chemically processed, or chemical treatment has been done for 1 day using some, we can go for any of these solutions like NOH, alkaline treatment can be there, or there are different treatment condition. We will not go into detail of this. If we are dissolving this Punica granatum fiber into NOS solution or alkali treatment for 1 day, then we are denoting this. And this processed chemically treated, this we are using 10 weight percent into the polymeric matrix. So likewise, we are having different state of conditions. Like again, if I say that Punica granatum fiber 5 day 40 means Punica granatum fiber was dissolved for 5 days into NOH or any other chemical treatment process, and 40 weight percent of what we have obtained means this total we are using 40 weight percent into the polymeric matrix. So these are the list of the initial list of the materials that we have identified. So there are total 17. Now for each of these material alternatives we have to obtain the various mechanical properties or the various criteria that I have listed in the previous slides. So what we have to do, like this are the criteria, again I have listed on this slide also. So these are the criteria. So testing has to be done in order to find out the various mechanical properties. So these are the tensile strength results that we had obtained for the various configurations, all the 17 configurations that we have considered for the green composites. So these are the variation of tensile strength. We can see that at a certain instance this is optimum, and after that it comes down. So similarly the flexural test results also we have found out on the basis of this in primary investigation, and we can see that there are only these 17 alternatives can be further screened down, and these are the final list of materials on which we have to perform the final analysis. Now which optimal reinforcement condition I should go for, so that I can have a material which can yield like maximum this optimal properties. These are the list of 6 alternative materials that we have gone for. So after the primary investigation, like after conducting the morphological or the mechanical analysis test results. So these are the criteria, and these are the now the alternatives with us. So alternatives are there, and the list of criteria are available with us. So on the basis of this, we have to formulate the decision matrix. So once we formulate the decision matrix, this decision matrix will be formulated, and yeah, this let me go into the decision matrix so that we can be much clear to you. Let me share one. Yeah. So this is where the decision matrix comes into play, and like various yeah, this is where the decision matrix, so it will open in the meanwhile. Yeah, so this is where the various alternatives were there, and once we have obtained the various alternatives, yeah, so as we can see that this is the Young's modulus is there. We have obtained for the various alternatives the tensile strength, the elongation at break. So different material alternatives, we have obtained this. So that is what I meant to say by decision matrix. This is the alternatives, and this is the criteria on the top. So this is now we have to fill up for each of the material by performing our initial experimentation, and once we do it, we'll be able to get some values. So these are the exact values of experimentation, or some average we can take if we are having a range of values. Okay, so this is the decision matrix. Now this decision matrix, we are going to normalize it. By why normalize? Because tensile strength will be having some unit, percentage elongation break will be having some other unit, likewise Young's modulus will be having some other unit. So these are having all different units. So in order to make them comparable, we have to have a common scale. Otherwise we will not be able to compare this. So we go for the normalization, and for normalization there are various formulas. You can just refer to the source cited for going into the normalization. So now we can see that these are all values are now less than 1. So now these are all on a comparable scale, and after this normalization technique has been performed, then we can go for the basic algorithm of the that is of TODIM method, where we have to find out the dominance score. Before finding out the dominance score, we have to find out the relative weights, like the weights for the various criteria we have considered, like the tensile strength, tensile modulus, flexural strength, flexural modulus, and so on. So these are the criteria. So we have to find out the weights. So for that we use an entropy method. So entropy method, there is a different altogether algorithm. This algorithm will help us finding the weights. So once the weights are found out of the different criteria, then we can go for the dominance score. So this is the basic formulation for the dominance score. And yeah, this is where after obtaining the dominance score, we will be able to find out the overall dominance score. On the basis of the overall dominance score, we have to rank the material. So this is how the algorithm will be functioning, and we have to have a strong mathematical skills into it. And also, if we are acquainted like with MATLAB, we can go for the codings and we can obtain the different values. Even the simple Excel, you can go for this calculation once we are clear with the formula. So once we have found out the overall dominance score, so you can see now on my screen, for each of the 6 alternatives, we have found out the overall dominance score. So this is the dominance score for alternative A1. For alternative A2, it is 0.69, 0.36, 0.45, 1, and this. So on the basis of this, the alternative that is having the highest overall dominance score, so in our case it is alternative number 5, that is having the highest dominance score of 1. So this algorithm says that we have to select the material that is having, or the optimal reinforcement condition, or the alternative that is having the maximum overall dominance score. So in this we are having alternative number 5, and alternative number 5, if I just take you back, then this alternative number 5 is the punica granatum fiber that has been dissolved for 5 days, and 30 weight percentage we are taking into account. Okay, so yeah, we can find this. This is the alternative number 5, that is punica granatum fiber dissolved for 5 days in some alkali treatment solution, like NOS solution, for 30, and we are taking its 30 weight percentage. So this is where it helps in reducing the optimal reinforcement condition. So this is where the decision support system came into play, and what proportion of the waste produced by the punica granatum fiber should be taken and should be treated chemically and mixed with the epoxy resin, so that we can have a suitable composite or the green material according to our requirement. So here we have seen that I have shown you that these were the exact values. So for more understanding, you can refer to one of our papers in fibers and polymers, and you can find out the algorithm. Now, whether this algorithm is reliable, whether this is performing a reliable result, so that we have to go for the test and validation. So once we are going into test and validation, we are seeing one parameter. What that parameter is there? So this variable parameter is there in this algorithm, and that variable parameter, if you go on changing that, you will be having different values. So this theta is the a prospect value. You will be having this is the theta you will be having. Theta is the variable parameter, and for this you will be having different prospect values or the overall dominance scores. So these theta values, if you are changing, then it might be possible that the values of the overall dominance score, that is these values shown by the red arrows, might change, and when these are changing, the ranking might change. So we have to perform the validation. So we have taken four values, like one is less than one is equal to one is slightly that is other are greater than 10. So when we say that theta basically depicts the risk appetite of the decision maker. So when we say theta equal to 1, then the decision maker is like neutral while making a selection. When theta is equal to it is less than 1, then we say that yeah, more it is more risk adverse. But when it is increasing more than 1, then less risk adverse is shown by the decision maker. So this is where we see that the rankings are not changing. So yeah, the results are reliable. The other things is that you find out the criteria weights, the importance weights. So these weights are now you have found out using some algorithm. That may not be these weights might change for the criteria, like tensile modulus might be some lower, or tensile strength might be higher. So different tests need to be performed by changing the criteria weights. So when you are changing the criteria weights, you are having you are seeing that almost the ranking results are not varying. So far we have seen that the criteria weights were exact. Okay, these were all exact informations were given to you. But if in case if I add an extra dimension, like apart from the technical parameters, if I chose to find out the optimal reinforcement conditions on the basis of some socio-cultural indicators, such as the aesthetic of the product, the labor availability in producing that product, the designer knowledge, the social and cultural identity, we cannot quantify these terms. We have to go for the linguistic approaches, and that is where the decision support system on the basis of on the basis of ML and AI comes into play. So this has been already we have addressed the similar problem, but with a great extension. And for a more understanding, you can refer to another one of our paper in Journal of Cleaner Production that has been recently published. So this we are not taking into this webinar. Maybe sometime if an opportunity is provided, we can go for the AI or ML based decision support systems. Now there is another example so I am taking on, that is for electric vehicles, and that electric vehicle we have to choose a suitable material for the leaf spring material. Okay, so this is another approach, that is the addition multiplicative approach, and you can refer to in one of our research paper, that is Arabian Journal for Science and Engineering. This algorithm and this case study has been published. So these are the different steps. Now what changes is just the middle part. You can see that the initial part of the algorithm remains the same. That is when we are dealing with the exact information. Okay, you have to identify the alternative criteria, you have to develop the decision matrix, you have to normalize. Then the last part also remains the same. Only the middle part now changes. So this is altogether a different algorithm, and this is an AMR approach. That previous one was the TODEM approach. Now this is an AMR approach. So in this, instead of performing the experiments, we have gone for an exhaustive literature review in order to find out the applicable, or we have to find out the suitable materials, because there are a large number of materials available for leaf spring materials, and we can see that there is a total list of 15 materials so far that we have obtained through an exhaustive literature review done till 2020. So these are the various criteria on the basis of which we have to select a proper leaf spring material for the electric cover. Now, for you should have also some design knowledge, like designer knowledge should be there. So what is this? Specific strain energy sigma square, that is a permissible stress, divided by twice of E, that is E is the Young's modulus. So we can see an spring that is having a good permissible, that is tensile yield strength, but lower Young's modulus. Young's modulus should be lower, and yeah, this should be higher, so that we can get a good value, good specific strain energy, because the spring must be able to absorb more energy with it. So, and it should release it very slowly. So the material which is having very high value of specific strain energy should be, or strain energy should be taken into consideration. Should have high impact toughness, so that it can take into account the galvanic corrosion. So this knowledge is also required apart from the decision support systems. So these materials are there and these criteria are there, and on the basis of some criteria you need to maximize, and some criteria you will be required to minimize. So the criteria that you are maximizing, these are known as the beneficial criteria, and the criteria that they are going to reduce are known as the non-beneficial criteria. Okay, so these are the two types of criteria apart from exact and non-exact informations. So when you go for the AMR approach, then we can have the ranking of the materials, as you can see on the right hand side of the screen, that on the basis of certain values, p values, here the p values have been taken into account. So the alternative that is having the highest p value is ranked number 1, that is now here it is alternative M11. So M11 was like it is epoxy resin with the e-glass fiber. So this is the best chosen alternative material for the electric vehicle that is under consideration. So this is published in one of the resources. So for this webinar, we have just kept for the exact information. So for the exact information, we have taken like almost all the steps remain same for the different calculations. I have shown only the middle structure of the algorithm changes. So there are various algorithms. So these are the simplest algorithms that we are approaching, because we are having the exact information. But once we are having non-exact information, like I told you in terms of green material, if you are including the environmental impact or the socio-culture indicator, such as the aesthetics or the labor availability or the designer knowledge or the social, so these aspects cannot be quantified. In that case, you cannot use the algorithms as it is. You have to modify these algorithms, and in that case, when these algorithms are modified, you have to take into account the uncertainty. So once you are taking into account the uncertainty, even the randomness, even the vagueness also, you need to take into account of the decision maker, because some decision maker will say that on the basis of the material that it is having good aesthetics. Some will say that no, it is not having good aesthetics. Some will say it is having an excellent aesthetics. So this is all dependent upon the decision maker. So the information is all uncertain. So we have to now go on the basis of AI or artificial intelligence or machine learning based decision making tools. So whatever the decision making tools we have studied, we have to integrate with these fuzzy logics and all, so that we can deal with the linguistic informations. And in that, the algorithm, although it becomes very complex, but we are able to take into account the different diverse criteria or the performance metrics into account, and our choice becomes more and more accurate. It becomes more refined. But going for this AI or ML based approaches, we should have sound knowledge of sound mathematical backgrounds, apart from good coding skills, so that we can code these algorithms. If you are more interested, you can just approach one of the papers, that is Journal of Cleaner Production, where we have proposed the modification of the TODIM method on the basis of normal, wiggly, hesitant, fuzzy sets. And these calculations are very complex if you go and you look into it, but this becomes a more refined approach. So TODIM becomes a more refined approach when we are going for the linguistic approach. Okay, so this is where we have taken the for this webinar. I have only considered the exact values, like the criterias, the performance metrics are exact. So somewhere you might have to go for the experimentation, like in the case of green materials, we have to go for the experimentations in order to collect the data. But in case of already available data, we can go for an exhaustive literature review, and once an exhaustive literature review has been done, we can collect the data. Or in some cases you have to go for the survey also, like if you go for the assessment of the renewable energy based power projects. So in that case we have to go for the surveys also, where you have to link up with the various decision making that is policy makers also. So there's where the important role in the decision support system is of the how you are collecting the data. So once the data is collected, then you can just plug in the algorithm and you can find out the values. And once the algorithm has been done its task, then you have to find out the variable parameter. So for the present case, you have to see that while providing the algorithm, which is the variable factor. Okay, so yeah, for in this case, this is theta is the variable factor. So we have gone for various theta values. We have reiterated the process with the various theta values, and we have find out the rankings of the various alternatives. So test and validation is one of the most appropriate way. Another process is you can apply this methodology to already solve past case studies. Okay, some studies have been done, and you can just approach that study and you can find out the correlation coefficient, that is the Spearman correlation coefficient you can find out, and on the basis of this you can see that yeah, algorithm is justifiable or it is producing good results or not. So yeah, Dr. Pradeep Karsh, are you there?
Yes.
Yeah, so how much time are we left with? Can you just let me know?
We have 10 minutes left.
Okay. So this is thank you, sir. So yeah, so this is where we have taken we have taken the 3 case studies. First was just the internal structure changes. That is what I mean to say when we are going for the exact values. Okay, so apart from this internal structure, the rest everything remains the same. First of all, you have to find out the list of alternatives. Then you have to go for, like, first of all, then you have to find out on the basis of what criteria, on the basis of what criteria are you going to evaluate these alternatives. So there may be long list of the alternatives also, and this process can becomes at times more tedious, because you have to go for like experimentation now for the 17 alternatives if the data is not available with you. But in case of the leaf spring problem for the electric vehicles, we have seen that there were 17 alternative materials available with this, but the data is already available in the literature if you go for the exhaustive literature review. So algorithm remains same, like you have to formulate the decision matrix. For that you require the data for the criteria, like for the tensile strength, for the mechanical properties, if I talk in terms of the green materials, or for even for the leaf spring material also, we have seen that there were density was there into account, impact toughness is there. So once this matrix has been formed, we have to provide them on a common scale, that is we have to normalize the decision matrix. So once then they become this, then we have to find out, we have to assign the weights to the different criteria. Okay, so the criteria C1, C2, C3 and C4, C5, different criteria can be there. The more exhaustive you make the list of criteria, the more judicious decision we will be able to make. So this is where we have considered, and the other algorithms are there, and COPRAs. Apart from that, I have already depicted in this figure, like there are various constituents and normalization tools, and weighting methods are there. Then various apart from this, we can go for various algorithms also, like TOPS is there, Vicar is there. So yeah, if we perform this experimentations, or the data collection is very much important. If the data collection is not proper, then obviously we may end up with telling the decision maker or the designer that a material or an alternative that may produce some erratic results. So for example, if I go for a leaf spring material other than the first one, or the other worst, if that is not available, and if the decision maker say apart from alternative, let me go to the leaf spring problem. Yeah, this is the leaf spring problem. So yeah, these were the alternatives. So if data collection for the various properties or for the various criteria is not proper, then we may end up suggesting a wrong material to the designer, and then we may end up an electric vehicle which is not means very much sound to for the passenger comfort. Okay, so data collection is very much important apart from the algorithm. So yeah, we have published numerous papers on the decision support systems. We have gone for concentrated solar power plants also, where we have gone for the vegetable oils, which vegetable oil should we go for, and various algorithms have also been proposed. So for this webinar, I keep this. You can just visit my these profiles, LinkedIn profile, Google Scholar profile, and ResearchGate profile for a more clearer view of all those algorithms. And soon our college will be starting with the different internship programs on the various research topics, and that will be rolled out soon. So if the students are in, or if any other are interested for their future PhD works also, then you can just contact me on my contact details. So yeah, thank you so much, Dr. Pradeep Kash, for, and also the PU administration for inviting me on this webinar. So
Thank,
that's it from my side. Yeah,
thank you, Bindani sir, for giving your valuable knowledge to our students, business scholar, and their faculty about this interesting topic. We appreciate you for getting the time and busy schedule. Thank you again, sir.
thank you
And
so much.
also, I'd like to thank you all the students and the faculty who are participating in this webinar. And if you have any doubt, any query, you can ask by sending mail to the Jindani sir. He will definitely reply you. And thank you, sir, again, sir,
Thank you so
for
much,
joining
sir.
this webinar.
Yeah, and thank you so much, students, and all the faculty members also who have been listening this webinar patiently. Yeah, thank you so much, sir.
Welcome, sir.
Yeah.
Yes, sir. Now you may live, sir.
Okay, thank you.
Okay.